Hi all. So let's get back to the studies again. First of all, let's recall what we did in previous video. Okay, so we started with numerical methods in which we were discussing prerequisite. In that also we did forward differences, forward finite differences. So what is forward finite differences? Let's give a quick review. Forward finite differences is given as delta. This is the notation for forward finite difference. Yn minus Yn is equal to Yn plus 1 minus Yn. This is the notation, or this is the expression for forward finite difference. If I express that in terms of function, as we know y is function of x, so x plus n plus 1 h minus fx plus nh, this is again the same value for delta yn. So if we just take any specific example, if I take n equal to 0, then it becomes delta y0 is equal to y1 minus y0. Here the thing to remember is finite forward differences are always denoted in terms of initial value as we are going forward. So we take the first value and then we go forward. So that is denoted by initial value. One thing I would like to correct, that in last video I forgot to write forward term there. I just wrote finite differences while I was telling again and again it is forward finite differences, but I forgot to write. So please make sure that you correct it in your notebook. Okay. So now let's go to backward finite difference. So as this title suggests, here if we were going forward, here we have to go backward. So backward finite difference of any function x is denoted by, this is the symbol for backward difference is nabla. How we pronounce it? It is nabla or inverted delta, nabla fx. And as y is function of x, I can denote it with nabla y also. Okay, so I have written this is known as nabla or inverted delta. So if we define this, what is the value of nabla fx? So nabla yn is equal to yn minus yn minus 1. So what we are doing? We are taking the difference of two consecutive values again. Here also in forward difference also we were taking the difference of two consecutive values. Here also we are doing the same thing. So if you give a moment to think, then what is the difference in computation? Exactly, eventually nothing. Whatever we are computing is the same. But here this symbol is changing. Nabla. Second thing, here we were using this initial value to denote that here we are taking the final value as we are going backward. So this is just the notation. In computation there is no change. If I write delta, it will be again yn minus 1, but this changes the meaning. And with this meaning, how we have to use it, where we have to use it, that also eventually changes. Okay, so now question comes that if final right hand side value, whatever table we are constructing is same, then what is the difference and what is the need for doing that in this why we have categorized it in backward and forward. So for now I would suggest that you leave it for the next topic. You will definitely understand that where we have to use backward difference, where we have to use forward difference. For today's video, we will just concentrate on how to construct and how to represent backward difference table. Okay, so I hope you all are ready. Let's write that in function form also. So if I write in function form, x plus nh minus f x plus n minus 1 h. So this is backward finite difference. Okay. So let's construct the table. I hope you all are ready with notebook, pen and calculators. If not, you please pause the video and be ready with that. So I assume that you all are ready with notebook, pen and calculator. So let's start constructing backward difference table. So say y is any function of x and some given data, some given values for x are x0, x0 plus h, x0 plus 2h, x0 plus 3h, x0 plus 4h. As I told you in previous video, these values of x are known as arguments and the corresponding values y are known as entries. Okay. So if these values are given, we can write directly. Otherwise, how we can find out? By substituting these values in the given function, and we can find all the entries corresponding to arguments. Now start with finding first difference. So what is first difference? How we define first difference? Nabla y1 is equal to, or just write the general formula, yn is equal to yn minus yn minus 1. That means next one minus previous one. So before starting, I would like to tell you some things that in some books, as it is backward difference, the representation they have changed. They have started with xn. Then going backward, if I take the one step length h, what will be the previous one? Xn minus h. Then if I go here, what will be the value? Xn, how many times we have come backward? 2 times. So xn minus 2h. Like that, xn minus 3h, xn minus 4h. So that is just the way of representing. Mostly in backward they go like this, in reverse. But if you understand, if I start from here, again I am going one less of backward of the difference of h only. Okay. So that is just the way of representation. Whichever you feel comfortable, you can go ahead with that. So now applying this formula, we have to start from last value. So we have to take the difference of these two. So difference of these two, y4 minus y3. How should I denote it? Refer this general formula. Now in backward, we denote that with the final value. So what is the final value here? y4. So this will be written as nabla y4. So that is the first difference, first backward difference of these two. Similarly, if we go here, what should I write here? Between these two. These two are done. Now these two. So y3 minus y2. How should I write it? Nabla y3. Then again y2 minus y1. This is nabla y2. Then again y1 minus y0. This is nabla y1. So what I have done, I have started from here and written like this. Suppose you start from here. That is also okay. If you write y1 minus y0, nabla y1, y2 minus y0, nabla y2, y3 minus y0, nabla y3, y4 minus y3, nabla y4. But while explaining, since we are going backward, we start like this. But eventually it is same thing. So anyhow you can do, just make sure that you are putting this correct symbol here, because if you have the habit going like this, then you may start writing delta delta. That will be forward difference table. So the representation will go wrong. Okay. So this is the first backward difference we have calculated. In the same way, we have to calculate this second difference. So again, let's start from here only. So delta y4 minus, sorry, not delta, nabla y4 minus nabla y3. This is equal to nabla square y4. Similarly, nabla y3 minus nabla y2. This is nabla square y3. This is nabla y3 minus y2 minus nabla y1. This is nabla square y2. This is just the second time difference. What is the difference between difference and differentiation? Differentiations are used for continuous function. We differentiate, and differences, this delta, that is used for finding the difference between two numerical values. Okay, numbers, if we have to find difference, then we use delta. Otherwise, do d by dx, that is differentiations. Okay, so now go to third difference. It will be delta square y4 minus delta square y3. What is this equal to? Delta cube y4. Then delta square y3 minus delta square. This is the difference of these two. Okay, and this is the difference of these two. So delta square y3 minus delta square y2. This is delta cube y3. Now we are left with two values only. So the fourth difference will be del cube nebula cube y4 minus nebula cube y3. That is nebula 4 y4. So again we have ended up. This table is terminated. Same way, if we are left with only one value, then it terminates, or suppose if we are getting all the same values at any point, then this table terminates. So I hope it is clear that in construction we are not doing anything new. The same we have done in forward difference table also, but notation changes. Please remember that since we are more habitual of calling it delta, we call it, but we have to put the symbol nebula, and we should try to call it nebula only. Nebula, this is nebula for backward difference, and delta, that is for forward difference. So construction, I hope it is clear that computation part is same, that representation changes, and obviously later you will understand that application is also different. So now let's try to understand how to construct backward difference table by taking one numerical example. So let's take this example to construct backward difference table. So the given data is, these are the given arguments or the values for x as 0, 1, 2 and 3, and the corresponding entries to these values are 1, 2, 1 and 10 respectively. So to construct the table, first we write all the values of x and y. So this is 0, 1, 1, 2, 2, 1 and 3, 10. So we have written the values, written the given data. The first difference, nebula y. That is the first difference we are going to find. So let's start with the final value. This minus this. What is that value will be? It's better if you write it here that this is y0, y1, y2, y3. It will help you to write the notations here. Okay. And if you want, you can write x0, but since we are not using it later, you can leave that. So I have written these values as y0, y1, y2, y3. So first I am calculating 10 minus 1 since we are going backward. 10 minus 1. How I should write it? Obviously nebula, that is the first thing, backward difference. Then y3 or y2. Since we are going backward, we have to take this value, y3. So what is the value of y3? That is equal to 9. Nebula y3 is 9. Now here 1 minus 2, that is equal to minus 1. What is this value? That is nebula y2. Then 2 minus 1. 2 minus 1, that is 1. That is equal to nebula y1. Okay. So you remember that you have to take this value first. If you are going in this direction while computing, that also you should remember that you have to take y1. That final value you have to take here to denote that first backward difference. So these are all first backward differences. Then second difference, nebula square y. So let's start with the final value again. This is, let's write it in this form, nebula y3 minus nebula y2. What is this equal to? 9 minus of minus 1. You please be careful while taking the signs, otherwise it will give you wrong values. 9 minus of minus 1, that is 9 plus 1, 10. What is this equal to? How we have to denote it? Nebula square. Y3 or Y2? Final value Y3. So nebula square Y3 is 10. Okay. So this is what we have calculated. Now let's calculate nebula square Y2. Nebula square Y2 is nebula Y2 minus nebula Y1, which is equal to minus 1 minus 1, that is minus 2. Okay. So these are the second backward differences. Now third backward difference. So third backward difference will be nebula cube Y3, which is nebula square Y3 minus nebula square Y2, that is 10 minus of minus 2. This is equal to 12. So we have constructed backward finite difference table. So again, if you compare, you will understand that while computing it is same, that eventually you will be getting the same value, but notations are changing because later on we have to use this table for some particular applications and forward table for some other particular applications. Okay, basically that difference you will come to know in upcoming videos. So I hope up to here this prerequisite how to construct table is clear to you. This will be the very first thing. Now onwards, in every video, every question, every topic, most of the topic will start with this, and after that we will apply it as per the required question. So please practice, please remember, please try to remember the notations, keep practicing, and see you in next video.